All right, anything you say can and will be held against you in a court of law. Yeah. Review. For the functions y equals a sine b bracket x minus c plus d or cosine, what is the median value? What is the median value? That's going to be one of those days. What's the period? 2 pi over b. What's the range? The range. The range would be the low value. What's the low value? D minus A, right? So from the midline. So if you sketch this out a little bit, right? That's B. Wow. So that's B. That's A. So this value here is D minus A, and this value here is D plus A. So the range will be from D minus A to D plus A, right? Square brackets, it includes. How can you find the maximum value? We already did, kind of. I don't know. We probably should have asked D and E before C. So what's the maximum value? So D plus A, right? So we go from the midline. The max is an amplitude away. And what's the minimum value? D minus A. That's where those need to be rearranged. Whatever. A function whose graph resembles a sine or cosine curve is called a sinusoidal function. Many periodic phenomena can be represented using sinusoidal graphs. A few examples are the height of a chair of a Ferris wheel as a function of time. Right? So if you think about it, you get on at the bottom and it goes up, right? You're going round and round in circles. Time of sunrise as a function of the day of year. Okay, so you can actually ask your smartphone, when will sunrise be on July 21st? Or sorry, June 21st, let's say that'd be the longest day of the year. When is sunset on June 21st, right? And we know this, right, because we can calculate these. We have a model. Depth of the ocean due to changing tides as a function of time, right? You got high tide, low tide, etc. The x and y axis will represent different units, but our knowledge of transformations on y equals sine x or y equals cos x help us to interpret the data. Unless stated otherwise, all application questions will be done in radian mode on your calculator. So 5 seconds, 5 meters, etc. will have the same value as if it were 5 radians. So that'd be x-axis. And actually, that becomes the other meaning of B. So B, in this equation, right? B is the horizontal stretch, right? It's horizontally stretched by a factor of 1 over B. It's the number of cycles in 2 pi, right? So you take the length of 2 pi, it's the number of cycles. And it's also now going to become a conversion factor from x-axis units, usually that's like a time axis, right, into radians. So it's got to convert it to radians, right? Then, because that, you're going to do this, right? You're going to shift it, convert it to, so take it in its x-axis units, say seconds, shift it by a number of seconds if the thing is shifted, then convert it to radians, dump it into the function, get the value, then multiply that by A and then add D, right? And you stretch and then move it up or down. A pendulum swings back and forth. The equation that represents the horizontal distance in centimeters from the 0 position at t seconds is h of t equals 5.6 sine pi t. In a question like this, assume the pendulum keeps swinging as if there was no gravity or friction slowing it down. If there were no gravity, there'd be no swinging pendulum. So say a frictionless pendulum, right? I mean, there's be no law, it's just going to keep swinging at the same rate forever. Determine the maximum horizontal distance of the pendulum bob from the 0 position. Okay, so how are we going to figure out the maximum horizontal distance? All right, what's the largest value the sine function can throw out at us? All right, you stick something into sine, you're going to get a number between what? We haven't modified it yet, just the sine function, we know it's between -1 and 1. So the biggest value we're going to get out of the sine function is 1, so the biggest value we're going to get out of h of t is 5.6. So the maximum horizontal distance, so when sine pi t equals 1, we'll have the maximum horizontal distance. Max horizontal distance. Okay, so therefore, the maximum horizontal distance is 5.6. 5.6 what? 5.6 days, centimeters, right? So watch your units, okay? Especially if you ever rewrite this next year for some reason. If you decide, hey, I want another crack at the diploma, then there'll be written response on there, right? And then leaving off centimeters is probably going to cost you. Determine the time it takes for the pendulum to make one complete cycle. Okay, so what's one complete cycle? What are we really looking for here, right? We're looking for the period. Okay, what is the period? What is B? And then don't forget your units, right? So 2 pi over the period, period is 2 pi over B. The B value is pi, right? 2 pi over pi is 2. It's period, so we're dealing with seconds. So on the t-axis, we're in seconds, and on the h-axis, we are in centimeters, right? Things that affect the horizontal axis, right, are B and C. Okay, the horizontal stretch and the phase shift. Things that affect the vertical axis, so those will be measured in seconds, right? If there's a phase shift, it'll be so many seconds. If there's a period, it's in seconds. When you calculate the period, it's in seconds. The amplitude and the midline, the median, will be in centimeters, right? They are h units. Sketch 3 cycles of the graph and label the axes. One cycle of y equals sine x is drawn on the same grid for you to compare the graphs and equations from a transformational point of view. Okay, so that's just plain old sine x. You've got to sketch this. So go ahead and sketch that. So at time 0, where is this? So time 0, we're working out the sine of 0. What's the sine of 0? Everybody say what the sine of 0 was? It's not hear you. Speak up. You're being recorded.
0.
0. Okay. All right, what's the period? 2 seconds. What do we split a sine function into? How many parts? 4, right? This goes back to beginning stuff. Split a sine function into 4 parts, right? So the first part is going to go, so from the midline, which is going to be at 0, right? There's no d value, so, well, the d value is 0, so we're here. So in 4 parts, right? We got 2 seconds, so 2 divided by 4 is 1/2. So everything's going to happen in a ½ second. So it's going to take a ½ a second, and where's it going to go from? Or go, well, it goes from the midline in ½ a second. Where's it going to end up? At the max. which is 5.6. In the next half second, where's it going to end up? That doesn't look quite like a half. So in the next half second, it's going to go to the midline. In the next half second, it's going to go to the minimum. In this case, it's going to be left. And in the next half second, it's going to go to the midline. And then it's going to go to the max, and then to the mid, and then to the min, and then to the mid, and then to the max, and then to the mid, and then to the... mumbling away at this point. Also getting ever higher maximums and ever lower minimums. Gotta stay level. And then we sketch away. Smooth curves, don't V it out. If you V it out, you're gonna lose. It's got to be a smooth curve, right? So by V'ing it out, I mean don't. It's not a sawtooth. All right, how's that look? So we're going to get to use that bit about, hey, sine function is divided into 4 parts, right? If I know the period, I divide that by 4, and I just say stuff happens in every quarter of a period, right? So as soon as I have any one point, right, or I know my max, I know my min, and I know my midline, and away we go. Okay. Any questions? Oh, determine the horizontal distance of the pendulum bob, 1.3 seconds into the swing. Okay, determine, can we do it off the graph, this graph?
Yeah.
Yeah, not with any degree of accuracy.
Yeah, no, that.
All right, so let's just see. So what do you think? I don't know, -5-ish. Okay, but what are we really going to do? So we're going to say h of t. This is our function, right? H of t is equal to 5.6 sine pi t. It's a pi t. H of 1.3 will be 5.6 sine pi, well, let's go with 1.3 pi. Pi times 1.3. Turn it on. No, wait, I want clear. Clear. Mode, what's mode got to be? Radians, okay. So make sure you're in radians, right? So this, you have to do this, you have to be switching back and forth radians to degrees, right? Okay, so 5.6 sine, and I'm going to put this in as 1.3 pi. Enter -4.5. That's a -5-ish. That's -5-ish. Did they say what to round it to? -4.5 centimeters. So for us in our frame of reference, that would be left 4.5 centimeters, right? It's gone to the left. Take positive would be swing to the right. Okay, questions? If all times are recorded using Mountain Standard Time, an equation that represents the sunrise times in Calgary over a year is approximated by T of n is equal to 2.17 sine 0.0172 bracket n plus 106 bracket square bracket plus 6.48, where T is the time in hours after midnight and n is the day number starting with January 1st. Okay, so these will be decimal times, right? In other words, like 6.5 would be 6 hours, 30 minutes, right? All right, one cycle of sunrise times is approximately how many days? How are we going to figure that out? Huh? What? How many days? So it's a period, right? Because n is the number of days, right? Okay, so how do we, so basically one cycle is period, right? What's period? 2 pi over 0.0172. Okay, which is equal to, somebody work it out. This is approximately, so we don't need like 6 decimals. 365.3. Wow, that's actually a year, right? Because the year is actually a little more than 365 days, right? It's like 365 and a quarter, which is why every 4 years we toss in a leap year. Unless it ends in double zeros, then it also has to be divisible by 400. That should not concern you. It had to concern me because I was around in the year 2000. So 2000 was a leap year, right? So if a year is divisible by 4, it's a leap year. Unless it ends in 2 zeros, then it must not only be divisible by 4, but also 400. So 2100 won't be a leap year. That might concern you. So 365. We're going to go with 365 days, AKA a year. It's a year. Wow, okay, that makes perfect sense, right? Write the earliest sunrise time of the year as it would appear on a digital clock. All right, so we're going to have to do a little conversion here. Okay, earliest, minimum. What's the minimum? Min is equal to D minus A. Formulas. I love formulas, right? They're great, right? Especially because they let me know what the heck you're doing. What the heck are you doing? Right? There we got it, right? This is what the heck we're doing. We're saying, okay, the earliest is going to be the minimum. The minimum is D minus A. Okay, what's D? Mm-hmm. What's that mean? So it means that the average time of sunrise, the median time of sunrise in Calgary is 6:30 a.m. Obviously. Okay, not quite, because it's 6.48, not 6.5. So around 6:30 in the morning, that's the average time of sunrise. Wait, somebody find out, when did the sun rise today? When did the sun rise? Wait, come on, one of these watch faces has sunrise on. Hey Siri, when was sunrise? Oh, God. So did you hear that Apple hired the head of Google's AI division? Try and make Siri less stupid. Sunrise was at 7:02. But in March 20th, sunrise should have been at the average time. Right? That's when you'd hit the... Anyways, D minus A. So sorry, what was that? 6.48 minus 2.17. What was that? 4.31? Okay, now, that would not show on a digital clock, right? 4.31. So that's 0.31 hours, right? So 0.31 times 60, we got to convert that to minutes. What's that work out to? 18 and change? 18 point who? 18.6. So our digital clock would show 4:18, right? If it had seconds, then the seconds would be 48 seconds, right? 0.6, oh sorry, 36 seconds. It would be 0.6 times 60, right? Because everything's decimal. The only time we actually do decimal time is when we get into seconds, right? And we do tenths of a second, hundredths of a second. That's when we get into decimal time. And otherwise it's hours, minutes, seconds. You're timing the marathon at the Olympics, you give the time as hours, minutes, seconds, and then tenths and hundredths of a second. Okay, so usually decimal time for us is when we start splitting seconds. Thank God, because the last thing we need is 60th of a second. And then okay, determine the day of the year which the sun rises the earliest. Okay, so we want to know when is that going to be 4.31. So what do we need this to be? Think. What do we want the sign of blah to be? -1, right? Because the earliest is going to happen when the sign is at its lowest, right? And when the sun is at its lowest. No, sun will be at its never. The sun also rises. Okay, so we want the time to be 4.31, so we're going to go 4.31 is equal to 2.17 sine 0.0172, 0.0172 n plus 106 plus 6.48. So the first thing we're going to do is subtract 6.48 from both sides, right? Giving us negative 2.17 equals 2.17 sine 0.0172 n plus 106. And then we're going to get negative 1, which is what we knew we had to get, right? We know we need the sine to evaluate to negative 1. 0.01, so sorry, sine 0.0172 n plus 106. So how do we get rid of that sine? Sine inverse. Yeah. So we're going to sine inverse both sides, right? And what is the inverse sine of yes? I don't know. What's it say under Q? Up to what?
Up to the equations of sinusoidal function.
Okay. Is that this?
Yeah.
No.
No.
What does it say?
I don't know. Is it?
Check. Including equations one, up to and including determining equations of sinusoidal functions. Okay. So now I got to turn this orange paper over and see it. Oh, determining equations of sinusoidal graphs. That was Tuesday, March 20th. It looks like. Okay. So what's the answer to your question?
This won't be on the proof.
There you go. Was it a question that needed to be asked?
I just couldn't find.
Oh, okay. Just had to confirm. Want to make sure. That's good. Be sure. Right? Better safe than sorry. All right. Give me an n. Do n. What's n? What sine looks like? Okay, got an n yet? That just says algebra, algebra, algebra. It's like we're solving an equation. I think you can do that.
Negative 197.
Wait a minute. Does that make sense? Negative? Yeah, so determine the day in which the sun rises the earliest. That doesn't make sense. That it would be negative. Anybody get a different answer?
Sine inverse of negative 1.
Sine inverse of negative 1 is.
What is negative 1?
Are you using your calculator to do that?
Oh, wait.
Yeah, it's giving you a negative rotation, right? Yeah, that's why I just wrote 3 pi over 2, because I know the inverse sine of negative 1. Try it with 3 pi over 2 instead of whatever number your calculator gave you. Be more positive. Do everything. So, okay, here's what you could do. So if you did do sine inverse of negative 1, right, and then you say, oh, I should try and be positive, so plus 2 pi. Okay, so there. Okay, and then divided by 0.0172. Ow, it never divides. Now I don't know what to do. Panic. Divided by, there we go, 0.0172, enter, okay, minus 106, enter, 167.9. What are we going to call that? 168. On the 168th day of the year. Hey, sir, what's the 168th day of the year? Use your iPhone, sir. You are useless. Somebody get out their Android phone and figure out what the 168th day of the year is. Say, hey, Google. Huh?
Hey Google, what's the 168th day of the year? Can't reach Google at the moment.
Oh, technology fails us.
Wouldn't it be June 14th?
I don't know.
Because it says June 1st is 152.
Oh, well, then it'd be 16 days after that, right? Oh, no, 16 days after that.
Yes.
So June 17th, which is pretty close to June what? 20th, 21st. But June 20th, 21st is what? The summer solstice. And summer solstice is what? The longest day of the year. So it would sort of make sense that the sun would rise at its earliest around the longest day of the year. Now, of course, we're Calgary, right? So we are going to differ from, if you're at the equator, well, if you're at the equator, it's all equal anyways, right? It's just like 12 hours a day, 12 hours a night, 12 hours a day, 12 hours a day. Nice temperatures, and it's not January 95th. There. Okay. From January 1st to December 31st, graphically determine how many days have a sunrise time before 6 a.m. MST. Okay, so everything's got to be in standard time, right? And I think what's happening is we'll get all of our times in standard time, then we have to like switch to daylight savings if we wanted to figure out, right? So what are we going to do this? Graphically determine. So we're going to go graph the equation. So it's y equals 2.17 sine 0.0172 bracket x plus 106 bracket again, and then plus 6.48. Okay. Window. So we figured out what was our min. It's like 6.48 minus 2 was 4.31, and our max is going to be what? 6.48 plus 2.17, so 729. Let's go 0 to 10, right? 0 to 10 by ones, and then our y values, years, right? A year. So what are we going to do? 1 year? Yeah, this is 1 year. So 1 year, so 0. No, that's y's, that's x's, sorry. X is 0 to 365. 365. And let's go by 30, which will be almost months. And 0 to 10 by ones. And, oh, we need 6 a.m. on here, right? So 6, graph. All right, so here's what is it? Sunrise. There's sunrise. There's our 6 a.m. Right? Determine how many days. Okay, so what have we done here? So y1 is equal to 2.17 sine 0.0172 x plus 106 plus 6.48. y2 is equal to 6. Our x window is 0 to 365 by 30. Our y window is 0 to 10 by 1. Okay, there's a little sketch. What do we got to find out? So, second calc intersect to get the x values. Okay, second calc intersect. Let's go to the straight line. So the first day, day 89.6, so day 90. And the second day, intersects. Let's go on the straight line here. If you want to trace on a different line, just use your up or down arrows. It'll move it from Y1 to Y2.
It's 246.
Enter, enter, enter. So 246. Okay, so 246 minus 90. So 156 days. Have a sunrise time before 6 a.m. Mountain Standard. So we should have used Saskatchewan because they don't mess with their clocks. Or Arizona because they don't mess with their clocks.
They don't switch times.
They don't switch to daylight savings time.
Why not?
There was actually a move. There was a bill in the legislature here to change it so we didn't.
Yeah.
You know, it's like, yeah, I don't know. It's.
What's the point of doing it?
I just like staying 2 hours behind the East because any sports you're watching, right? It's always going to end at a reasonable time. You get these World Series games going to one. There might be 1 in the morning there, but here it's like 11 o'clock. So it's not so bad. Okay, so graphical. Show Y1, Y2, right? What am I graphing? Here's my window. Here's a sketch. This is what I'm doing. Here's my calculation after I did that. Okay, questions, comments, concerns? We're running out of recording space. The piston in an engine moves up and down in the cylinder. The height, h, centimeters of the piston at a time, t, seconds. It's given by the formula. H of t is 20 sine pi t over 0.025 plus 20. Determine the piston's max and min height. Did I miss anything? What did I miss? Was there more here? Oh, describe the discriminants of parameter d in the equation. Oh, what's d? Well, we already sort of talked about this, but what's d? The median, kind of average, time sunrise in calc. Okay. So you could do is you can get like time data is exact, right? Because we know we have a really good model for that. Temperature data obviously not exact because there is no way to model that. But you can get average temperature over the last like 100 years, so you kind of have an idea as to what temperatures are going to be if they follow historical trends and that. And you can create a model for it, right? But a temperature model obviously is not going to be as accurate. A time model will be accurate. Okay, ready. Piston. What's the max? What's the min? Like, who wrote this question? It goes from 0 to 40. You know any engines that are this big? Like the cylinder is like this. Right? Like that's 40 centimeters. Like, I don't think so, right? Like, it's like a giant engine.
Well, maybe not on a car.
Yeah, truck, monster, the big earth movers they have up in Fort McMurray or something. Maybe you gotta, whatever. Hey, if it was smart, it would be electric and there'd be no pistons. Also a lot faster. Gotta get myself an electric motorcycle one of these days.
Tesla.
The Tesla of bikes. Well, you know, I mean, what's the Tesla Model S, the one that's not out? No, the Roadster. What is the red one? 0 to 60 miles an hour in 1.9 seconds. That's in. No, that's ludicrous. They're very small. What's the length of one cycle? How'd you get that? What's B? No. Yes. So B is pi over 0, right? It's whatever's in front of the t, right? So it's that thing. It's pi divided by. Right. I mean, 2 seconds, like, as ridiculous as 40 centimeters is for the length of the cylinder, 2 seconds is kind of ridiculous for the time of an engine. You wouldn't go very far. You move this far. What's the next? So the period is 2 pi over b, which is 2 pi over 0.025, which is what? How much?
0.05.
Sure. Is that what other people got? Yeah, it makes sense, right? Because the pi's are going to cancel, that's going to flip up top, and it's going to be 2 times 0.025. 0.05 seconds, 5/100th of a second. Engine's running pretty slow, I think, at that one. Okay. That's that. Okay, so basically, here's the deal, right? Given an equation and a context, you work stuff out, right, in terms of the context. So given that that is the height of a piston and a thing, then it has a minimum height of 0 centimeters. Makes sense. You're basing it at the base of the cylinder or whatever, and it goes up to 40, which doesn't make sense if you know anything about engines, really. Tidal heights. Throughout the day, at a particular location, be modeled by sinusoidal functions. The Bay of Fundy records some of the world's greatest differences between high tide and low tide levels. The following table shows the high tide, shows the tide levels at a particular spot in the Bay of Fundy over a 24-hour period on August 20th, 2012, beginning at midnight. Graphing calculators can use these points to come up with an equation that best suits this data. For this data, the calculator gives the equation, so we're not going to make you do it, but basically, we left from 30-2 in here. In the -2, we would do a regression equation, right? In -1, we don't do regression functions, but basically you can put this data into your calculator, you put this into L1, you put this into L2, and you ask it to give me a sinusoidal equation, right? I know this is defined, right? I know tide heights are going up and down, okay, in a wave-like pattern. And so this is what the calculator would give me, where values have been rounded to the nearest hundreds. For this equation, y represents the height of the tide in meters, which we misspelled, meters, and x represents the time in hours after midnight. This is called a regression equation. It's an equation generated by your calculator that will pass through or come close to passing through as many points as possible. In other words, basically what we're doing is we're taking our observations and we are creating a mathematical model to describe this, right? And when you go on to post-secondary, you're going to see a lot of mathematical models describing whatever it is in whatever particular field you go into, right? So you could be looking at stresses on a wire or something like that. You could be looking at stress on a bridge, You're going to build a bridge. You want to be a civil engineer, you're going to be designing bridges and stuff like that, right? So you look at the different materials, and you'll have equations to describe for you various stresses and so on, right? And then you don't have them collapsing onto the cars in Florida and killing people. It's like, why didn't you close the road when you were going to do that? And now the engineering community has learned from that. Okay, we're just not going to raise this thing while there's traffic going underneath it. Stuff, because we just got sued big time. No, it is beyond the scope of the curriculum to get your calculator to generate this equation. It's something you'd like to explore, ask your teacher. Don't all ask at once. No. Okay, enter this regression equation in your calculator. Okay, so we're going to put the equation in. So normally, if you had done the regression, you would have the equation sitting in your calculator, right? It would be in Y1. Okay, so but here's what we're going to do. I'm just going to go to y equals, and I'm going to clear out everything that's in there. Clear, clear. Okay. Okay, put the equation in 7.21. Sine, we got a bracket, 0.54 bracket, x plus 0.16 bracket, bracket, plus 6.58. Okay. Then what? To the neatest tenth. Nearest tenth. State the period of the graph to the neatest tenth. What is the period to the neatest tenth? Okay, what's B? 0.54. What's 2 pi divided by 0.54? Wait for it, it's going to be around 12-ish? 11.6? 11.6 what? Units. Hours. State the height. State. The high tide height. What's the high tide height? Yeah. So you don't have to write this max equals D plus A equals whatever plus whatever. What are the whatevers? I don't know what the numbers are.
No, 7.21 plus 6.58.
All right, 13.79. 13.79 what? Meters. You just use an M. That way you're not confused as to, do I spell it ER or RE? You spell it RE. Unless it's like an electrical meter, then you spell it ER. State, to the nearest tenth, the height of the tide at 4:30. Hint, need to change the hours and 30 minutes into strictly hours, which is going to be what? 4.5. Okay, so 30 over 60, right? We're given 30 minutes, 4 hours, 30 minutes, right? 4:30. So that's half an hour, 30 over 60. Right, if we're 17 minutes, you go 4 plus 17 divided by 60 to convert minutes into hours. All right, what is to the nearest tenth the height of the tide at 4:30? 4.5. So probably the easiest way is, because we've got this going here, is I don't want the window to go from 0 to 365 because, you know, like 24 hours is plenty. And what was my maximum was 13, and my minimum is, I don't know what, negative, so let's go -5 to 20 by 5s. Window range. All right, what did I mess up? Go to low. Oh, I got a scale of 20. Oh, okay, sorry. Why min? -5 to 20 by 5s. Okay, second calc value, 4.5. So if you can do stuff on your calculator, nobody cares, you know, so 10.8 meters. just says state. Your entire diploma exam is state, in a sense, right? Because you don't have to show any work. However, do the work on the page. Don't touch your bubble sheet until the very end, 6 hours in, if you're gonna, nobody's but put your bubble sheet away, don't touch it until you've gone through and you are now done. When you're done, then do your bubble sheet. That way you don't have to erase anything, right? If you're filling it in as you're going along, you're gonna go back and check, you're gonna wanna change things, you're gonna try and erase it, you're gonna end up ripping the page or crumpling it, right? It's gotta be read by a machine, so don't touch it when you're done. Do everything in the booklet, okay? Absolutely everything. Show all your work, show all your work. I mean, you should still do your work. And then, when you're done, sit down, fill in the bubble sheet, okay? Like go through step by step. Because the numerics are mixed in, right? Like you got, it's just like any of our tests, right? You got like 3 multiple choice and a numeric response. Same thing on there. So just, go, okay, multiple choice 1, A, multiple choice 2, B, numeric response 1, 7.6. Make sure you bubble the numbers. Don't just write 7.6 in the box for numeric response. If you leave it blank, you will get a 0. Okay, even if you wrote in 7.6, if you do not bubble the 7.6, then before you go, make sure you take your numerics and just run down every column and make sure there's only one bubble in any particular column. Okay. A boat was docked at this particular location at midnight because the captain was getting some much needed sleep. However, the boat requires a depth of at least 4 meters of water. Graphically determine the time as read on his digit watch. See, that doesn't work either, right? We just still got it. Well, we still have to convert. In which the captain must leave this location while maximizing his sleep time. Okay, so we're going to go back here. Got a nice little graph. I'm going to reset my window and just say 12 hours will do here. 12. And we'll go to y equals, and I want 4. So, where's that? So it means he's got to leave here, right? So it's like high tide, but he's got to leave at this point. So second calc, intersect. Oh, look, it's there. 1, 2, 3. 6.335, so call it 335. Okay, so here's the deal. X, right? We need the 0.335, blah, 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 okay? So here's what we're gonna do. We go quit, go x minus 6, right? That's the decimal part, times 60. Okay, so that's 20. Okay, so that's 620. Right, so at 620.12, it will still be above 4 meters. Right, so at 620, it's going to be so 0.3354489 times 60 equals 20.12. So 620, as shown on his digital display. Now, if you're smart, you're leaving at 6. But not. Okay, questions? Let's say determine anything here. Oh, graph. Oh, well, we got to do the whole thing, right? So y1 is equal to the equation. y2 is equal to 4. 0 to 12 by 1s, whatever, negative 5 to 20 by 5s. Sketch looks like. Second calc intersect. X equals. Be a little louder. People on YouTube want to hear you. X equals, blah, and so on. Yeah. Determine the approximate number of hours rounded to the nearest hundredth that a person could stand on the ocean floor. So if the water level is 0 meters. Okay. It says determine, right? So we actually have to show some work again. So y1 is the equation. y2 in this case will be 0. Your window can be the same. Approximate number of hours, there's 100%, and the y values. And let's go here and change that to a 0. And then graph, and we've got okay. So we need second calc value to get the x's. Second calc intersect. I could also use zeros here, but oops. 1, 2, 3. So 7.79. And actually, let's go a little bit further out because we got to round it too. So 7.78674. Okay, we're going to use that. Here's what I'm going to do with that. Second quit. I'm going to get out of there for a second. I'm going to take x and store it in A. Oops. Okay, so I'm going to take that x value and put it into A, right? Just alpha A, just alpha and this, the store. So take x, store it into A, right? That saves the x value with all its decimals on it, okay? So now I'm not worried about when I round. Then I'm going to get the second x value. So I'm just going to go back to graph, go second calc, intersect again. This time move to the other spot. Whoops. 1, 2, 3. Okay. 9.346. 3, 4, 6, 5, 4, 4, 8. Okay, that's in x. So we're going to take x minus a, because I stuck that number in A. Okay, and we get 1.559, so 1.56. Okay, so time is 9.346, blah, 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 minus 7.786, da, 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 1.56 hours. Okay, so about an hour and a half, right, a little over. Yep.
So it just asks how many hours, and you have to use the second part of the graph or goes 0.
That's what I did. I found this time and this time. Right. So the time from when it hit 0 to when it goes back to 0, right? After that, it's below 0, right? Which means the tide is out, right? There's no water at, wherever the 0 level for the Bay of Fundy is, right? Which would probably be like around the shoreline or something like that. So, yeah, tide's going to be out.
I asked this.
That's okay. All right, we good? Any other? So we got to change neatest to nearest and meters to meters. Oh, and we can end this